I have prepared this talk in English and German, so I try to. I don't have so many slides, so I'll try to keep it loose, and feel free to ask any question at any time if you want. So, one of my biggest interests, let's say, is unit testing and testing in general. So, testing automation is something that I really enjoy doing, and even one of the ways in which I started developing in general. So I started developing with Laravel and started with a lot of unit tests and started test-driven. And I try to apply this philosophy, let's say, in the current day-to-day working with Magento 1. Testing Magento, especially the first version of Magento, is not so easy because Magento is a big framework, and testing the single modules is sometimes very difficult and very complicated because you have a lot of dependencies to take care of. So it's not always easy, let's say. And there's a lot of memes. If you go and see videos on the internet about testing Magento 1, you look for documentation, you always have the feeling that it's impossible. You get the feeling that writing solid unit tests for Magento 1 is very complicated, and if you tried it, you know that it's true, because you have to install the several frameworks. There's not really a standard framework used for unit testing. Working just with PHP unit and Magento doesn't work out of the box, so you have to write a wrapper. We have to install a wrapper around it, so it's not really the easiest of things. So many other frameworks have the unit test suites already integrated in the framework, but this is not the case for Magento 1. With Magento 2, everything is different because you can write unit tests. You have the test suite integrated in the Magento framework, but with Magento 1, one does not simply unit test it. You have to work on it before you can reach a status where you can accomplish some tasks and write some solid unit tests. Unfortunately, this brings us to the point where we often write shops and modules without really testing them. So we don't really have unit tests for them, and we always have to do that manually afterwards. And that's not the ideal way of developing some software that should be always there, that should expect a lot of visits. So let's say something that should always be online. And so it's way more difficult to maintain. The maintenance of such software is way more difficult than afterwards. So we don't always write unit tests at the beginning because it's a lot of time investment. So you have to invest a lot of time before you get to a working system, and we have to face the bugs afterwards. So with this talk, I want to tell everybody that this is actually a myth, because you can write a unit test, you can configure your framework to work with unit tests in actually not so much time. I will try to do it in just 10 minutes, and I hope this works. And I hope you can. I hope I don't fall into the situation where I say, okay, it's possible in just a minute, and then I find a couple of bugs, and then it doesn't work. But I will try my best. I tried this many times; it always worked. And by the way, after you set up this once, you can be sure that you can always use this strategy to work with tests with your modules, and then you can rely on this test shop that I will create to test your modules on it.
When do I start the 10 minutes?
You can start them as soon as I open my 10 minutes. Not yet. Okay, not yet. That wouldn't be fair. So I have to say a couple of words before I start really with the setup of my testing environment. So basically, the basic structure depends a lot on the Magento structure. Magento is a monolithic framework where you can work on features modularly. So you can install modules, you can create your own modules, and you're supposed to write unit tests for the single module. So you could also write unit tests for the whole shop, let's say with the modules integrated, but it's way better to write unit tests in this case just for the modules, in order to be sure that these modules will work with every shop. So you can reinstall the modules on several shops. So basically, the basic structure for Magento is like this. You have a shop and you have modules installed on it. You have a shop, another, and you have another 2 modules installed on this shop as well. And then what happens? When you start writing unit tests, the first time you think, okay, I have to test this module in this shop, or this module in this shop. But sometimes you have incompatibilities because in the shop A, there might be a lot of modules installed and some of them might have already broken unit tests, or maybe there's a particular install script that breaks the whole setup process, so it's really complicated. And you get frustrated and you give up. So this is what happened to me at the beginning, because you have a lot of things that don't work out of the box when you have to create a new database to work on it, because the unit tests need an empty Magento database. And then the thing is, you give up because you don't know how to go further. The idea that I tried to apply and that I discovered it works is to create a separate test shop, and then to link all these modules in this test shop, and then to test the modules in a separate shop. Like this way, you can make sure that the test will run on any shop, and you don't have to rely to the structure of the shop A and shop B in order to run the unit tests. So if you can run the module tests on this shop or on any shop that you create from scratch, then you can be sure that the tests are running and that you don't have any conflicts with any other database data that you have saved in shop A and shop B, that you don't have to take to care about them, because you have an empty database in the test shop. So this requires a bit of configuration. There is a one-time configuration, which is something that I will do in 10 minutes right now, and Marcus will take the time. And this is a one-timer, so you do it once and it's done forever. And then you have to set up something for the module as well, and this is something you have to do each time. The one-time configuration consists in setting up a dummy shop only dedicated to the unit test, and this can be done very quickly with shell scripts. Then you can have to create an empty test database for the unit tests that will be used only for that. You have to download the scripts that I wrote, so you don't have to work on that, because I already put the scripts online, so you can only download them and just test on it. And configure the testing framework to populate the test database. This is done just once, and I will show you it doesn't take long. Then there is the module-specific configuration, in which you have to create the test suite classes and the configuration file in the module, but this is also very easy. Deploy the module in the test shop, so you have to link the module to the test shop to run the test. And you have to write the test, and this is something that you do while you develop. And then you have to run the test in the test shop each time. And this is something that belongs to the workflow. But the one-time configuration is very easy. I will try to show you very quickly how it goes, and I hope it doesn't take too long, and I hope I don't bore you too much. Testing. Okay. So. Yes. I will do it way bigger than this. Let's see. Okay. I hope you can see. So first of all, you have to set a couple of variables in the terminal. You have to set these variables here. You're just saying these are the coordinates, the variables that the tool will use to install the Magento test shop. It's an empty shop, so it doesn't matter. This is a fake URL, and this is the directory where it's going to be installed. This is the Magento version that I'm going to be using. Actually, there is a tool called MageRun, which every Magento developer knows. And MageRun is an automation tool, so basically you can automate a lot of processes with MageRun. One of those processes is installing a shop from scratch. And once you set these variables in the terminal, you can execute this command. And this command installs the shop in a few seconds. Because it downloads it, it takes all the variables, and installs Magento in the directory that we chose. So we go to the Magento installation folder, which is there. And now we go to the next step. We have to install a testing framework. The most used testing framework for Magento 1 is a wrapper around PHP unit, which is the most well-known PHP testing tool, the PHP testing framework, I mean. PHP unit is not enough to work on Magento. So you have to download and install in the shop this wrapper around PHP unit, which is called ecomdev PHP unit. And I will just install it like this. I will install it inside the test shop, because so this way we will have everything in the test shop and we don't have to work outside of it. Everything is self-contained in a single directory. It takes a little bit on my computer because I have Xdebug installed, and that makes the process a bit slower, but it should be done pretty quick. Let's see. It's loading the composer, updating the dependencies. Xdebug. Xdebug is a debug tool for PHP. So you use it when in order to start debugging the code when you start the debug. And yeah, it's the standard PHP debugging tool. Then you come to this point where you have to set the Magento root directory. You have to tell this module of the composer installer where the Magento root directory is. To do that, I will just print the working directory, copy it, and paste it here. And that's done. Okay, so we have a Magento installation. Okay, well, that's very bad. A Magento installation here, and the PHP unit is installed in the vendor folder, so where the dependencies are installed. Next thing that we have to do is we have to download the script. This is a script that I wrote that configures the testing framework, ecomdev PHP unit. We install it there, and it's here. Next thing that we have to do, it's a lot of things, but it's once you have them on a list, it takes not too much. We have to log in into MySQL. And we have to create an empty database. We have to create an empty database for the unit test because we cannot work with the shop database. We need to set fake data in the database, to save fake data in the database, then we have to delete them. And PHP unit does that automatically. So if we work with fixtures, we need the order table, for instance, to be empty. We need to delete them each time after the tests are done. And so we cannot work with, even with the test shop where we want to have our test orders or our test customer and stuff like that, that will delete everything. So we can work with that, but we have to work with the fact that it deletes everything. I will just create an empty database. That's a good name. This is empty. Oh wait. I will use the database and show the tables. No tables inside it. The next thing to do is to use the script that I have downloaded. We can just run it like that, and it will tell us that it needs the database name and the base URL of the Magento shop. So I will give them to the script. The database name is blah blah blah, as we've seen. Sorry, and the Magento base URL is sorry, no, I didn't want that. Ah no, of course it's not there. It's sorry, yeah. Too much stuff. And then it configures the database automatically. We're almost done because the next thing that we have to do is we have to execute PHP unit. And this is done by running the PHP unit executable for the first time. It takes like 30 seconds because the first time it's populating the database that we just created with the Magento tables. So it only takes the Magento installation that we have, in this case it's Magento 193.10, and it populates the tables here inside to use them for the unit test. So the first time you run the test suite, it will take 30 seconds more or less, and it writes all the tables.
One question. You named your database blah blah blah.
Yeah.
But that's good what you wrote. It's just assigned the name of the database in any configuration file. Wait, can you say something?
Yes, this is something that I've done when I've run the script. This script here.
Yeah.
So the configuration script that I have
so it's
downloaded.
written in the local XML
Yes.
shop or somewhere?
There is an additional local XML called localxml.php unit, and this is the place where PHP unit takes the database name for the test. So it took, this is good, a failure is perfect. So
If it says good, then it's
yes,
good, right?
perfect, it's
If it
perfect.
says okay, then it will be an error, right?
Yes, yes.
Okay.
It's like sometimes it's like that. And to see that it's good, I will just try the same command that I've done before, so show tables. And we will see that we have a lot of tables here. But we can see that we have the tables that PHP unit created for that. So it created really a Magento database. Sorry, I didn't want to do that. Man, yeah. Okay. The next time, if we run that, as you can see, it took 30 seconds, 31 seconds. The next time, it only takes half a second because the tables are already there. So the database is already populated. If we want to start testing right now, then I have a test module that I've written, and this is just a module creator that I've written, and you can download it in the Magento directory just to have your test run in the proper way. So we'll make it a bit bigger like this, and we will install it in the shop with Modman. So I will do Modman init the first time and Modman clone the module, and then it will be installed in the shop.
In which directory are you?
I am in the Magento directory, and here I have the Modman module schedule. I've downloaded it there. Now the next time that I run PHP unit, it passes, and it passes because I have a unit test here. Sorry, it's here. A unit test that say accepted true is true, and this is the reason why the test is passing right now. If I change it to false, of course it's gonna fail. And I know this might look a little bit of stuff, but actually you've configured on your computer the way to test all of your Magento modules, because the next thing that you have to do is to link the next module that you've written to this Modman directory, deploy it there with Modman, and then you can start your unit testing there from scratch. And then you can work, even if you have your module inside another shop, so you can test it visually, you can go in the backend and test the functionalities of your shop. In the shop where you want to develop the module for, then you can also run the unit test in a separate shop. It doesn't matter. It matters if you run them there, because you should be able to run them regardless of the shop that you want to deploy your module in. So your test should always run in every shop. Okay, so that was it. It took 30 minutes more or less. I hope it wasn't too boring.
No, it was almost 9 minutes.
Almost 9 minutes. Very good. Very good. Okay, so that was the one-time configuration, let's say, and the procedure to run the test in the test shop.
Sounds very easy. Even I can do that, right?
Yeah, of course. No, I mean, it's a lot of stuff, but actually we have published 2 blog posts. I will give you the links afterwards. Or you can go to my Twitter account, and I've published the link to the post there, to the blog post. There is one in German and one in English. And the one in German is published on the Lemundo blog. The other one is published on Medium. And I basically describe the whole thing that I showed here. So you have all the commands, all the variables, everything, so all the references. So it's possible. It's possible to do it. But of course, this is for testing on your local computer. There is another opportunity if you want to integrate the tests and the test suites of your modules in your CI/CD workflow. So if you're working with a team, and you want to make sure that everybody writes according to the test that you've already written, and then the next developer, which will be you in a month, works on the module, doesn't break the test that you've written 1 month in advance, 1 month before, then you can even make sure that the tests are run by every push to the repository by just integrating the test suite in the CI tools of your choice. For instance, we use GitLab at Lemundo, and GitLab offers a very broad spectrum of opportunities if you want to run your integration test and your unit test directly on the platform. So you just have to write a bit of configuration and then you can run a unit test there. In order to allow for that, you have to use a tool which is written by the fabulous Magento community. There's a big community who wrote a lot of tools, you just have to discover them. In this case, the tool is called Magento. It's written by a company called AOE People, which is a German company. And the original repository is here. And I forked the repository to allow for unit testing on GitLab CI as well. Because the original one only allowed for testing on Travis CI, which is an open source continuous integration tool. But with this fork, you can also use GitLab CI to work on it. And it contains the latest Magerun tool version, which allows you to install the latest Magento versions. So you can test with the latest Magento versions as well. With GitLab, this is how it looks like. You automate the test execution and you can execute testing pipelines. So the same unit test that you can run on your test shop locally on your personal computer are also run each time you push the repository. You push to the repository. So every commit starts a testing pipeline, and this is how it looks like. Okay. Here, first of all, there are instructions for anyone who's interested. I think I will put the slide somewhere afterwards, so that you can also have the links. But I want to show you an example of a pipeline execution, which is how it works. So basically, oh, sorry. It doesn't work here. Wait a second, because I'm on the wrong browser. I'm in this one. Yes, I want to go there. Okay, this is a module that I've been writing. And these are the pipelines. So basically you can see by every time I push there, a pipeline is run. And sometimes it fails, and most time it passes because I run the test locally as well. But you can imagine working with other developers. Maybe sometimes not everybody's running the tests, or maybe somebody is running them every once in a while, but at the latest, at the moment where the push comes to the repositories, you will make sure that the test is passing or that the test failed. And that gives you a good overview of what's going on with the module or with the shop. So basically what the test suite does is install a complete Magento repository, a Magento version with Docker on the GitLab CI environment, and then deploy the module on the Magento version that it just installed on Docker. Create a test database. Everything that I showed you, it's basically automatable, so everything can be automatized. It installs that on Docker. It runs the test against this empty database, and it takes 4 minutes to do all of that, because he has to populate the database and run it. But in the end, what you've got is something like this, where you can click and you can examine which tests have been running and if they passed or not. And if they didn't pass, why they didn't pass. So what is the reason why they failed. But this gives you, especially when you're working on a bigger project, a lot of confidence, because you can refactor, because you have a lot of advantages if you work with unit tests from the beginning. And yeah, so basically that's it.
And what happens if it fails?
Well, if it fails,
a red light or something?
Yes, if it fails, you will see something.
That never
Talking about integrations, you can also think about a red light close to the desk of the developer who pushed the changes.
That would be nice.
Great. That would be really good. Or like a red light pointing to the developer. Yeah, that would be great. Now, in this case, you only get an email. If you push to the repository, GitLab sends you an email and say your pipeline was broken. So you have to go there and fix it, because otherwise the next developer is going to have a hard time. Like, this is what it looks like if it's broken. You go there and you see, well, job failed, and you can check what happened. So this was just a connection problem. So the next time that I run the pipeline, it worked. But this is not always the case. Okay, so that was it, more or less. The posts on this testing series are available on the Lemundo blog, as I told you, in German, and on Medium in English. So you can pick them as a reference if you like this way of testing Magento 1 modules. And you can also find the links on my Twitter account, or you can also find the tools that I use on my GitHub account, because some of them are just available, freely available on Git, and I've pushed them as GIS. And that's it, more or less. So, yeah. Yes.
I have at least 2 questions.
Yes.
I think. So better get prepared.
Okay, let me bring something.
So first question is,
Yeah.
I can understand that you need a database for doing integration tests, but do you really need a database for doing unit tests?
You don't.
in Magento?
You don't really need a separate
Okay.
database.
So all of your steps are
no,
not
wait.
necessary if you only want to do unit tests.
Wait a second. You mean a database in general?
Yes.
If you're running unit tests.
Yes.
Sometimes it's very hard to decide which where is the border between unit test and integrations test in Magento.
Database.
Yeah, that's correct. That's correct. But sometimes, in most cases, you have to. It's really hard to tell. But let's say then in this regard, I will say I'm writing integration tests more than unit tests, because I'm working more with the database than just on the classes themselves.
Yeah.
Because I'm writing a lot of unit tests where I just test the functionalities of my function, so the expected return values and stuff like that. But even for the configuration, Magento is a configuration-based framework where you have to write a lot of configuration in XML, and this gets copied in the database, basically. So even for basic configuration, you have to make a query to the database.
Okay.
So it's not always like in other frameworks like Laravel, you have an environment file where you have all the configuration set there. Even for the base URL, you have to query the database in Magento.
Yeah.
Because it's all written in the core config data table.
Okay.
So that's the reason why it's a bit hard to tell. You have to use the database a lot. So I think unit testing without the database is really hard to do. Though you can do it exactly the same way, so you don't need the database in that case.
Okay.
But you will need it in any other case.
Okay. Thank you.
What's the difference between those two?
Between those tests?
Yeah.
The test types, so integration
Yeah.
test and unit test. Actually, the difference is really the database, as Martin told, because usually when you have to work with data, being written in the database and then making queries in the database, the things get a bit more complicated, because you don't always have, you don't just have the functions that you've written in your classes, or maybe the object that you can pass here around, but you have to work with an external system, with a database system. And you have to write fake data there, and you have to get this data and do some operation on it, and then return it, and then make some assertions on this return values. So basically you have to interact a lot with the database. And this is almost impossible to avoid with Magento. So I will say yes, basically you're writing integration tests all the time.
Okay.
Yeah.
So this is a little bit slower than just doing unit tests, right?
Yes,
Because that's the benefit of doing unit tests. You can just run it every time. You know, it's just a matter of milliseconds.
Yes, yes.
Yeah.
It's not that quick if you're working
Yeah.
with the database, with the integration tests.
Yeah, I
That's
know.
true. For instance, I will show you one thing, just one little thing. So I've written some scripts to integrate the whole thing. So this is in a separate directory, and I have my editor console here where I can just run the unit test in the test shop from the directory from where I'm in.
Mm-hmm.
So this goes only like this, and I will test it in playground, and now you will see how long it takes. It doesn't run as smoothly and as fast as with the normal unit test,
Yeah.
but it doesn't take too much either.
It's just one test, right? Or how
No,
many
these
tests?
are 15 tests.
Oh, 15, okay.
15 tests
Yeah.
with 65 assertions.
Mm. It's not that many tests actually, but
No,
okay.
not that many,
Yeah.
because I'm still working on it.
Gotcha.
But you know, even a couple of tests is better than no test.
Of course.
Yeah. So
Okay, no question about that.
How do you decide how many tests you need?
it depends. So
As many as possible.
But you can write tests all
Sure.
the time.
No,
Well,
I
you
don't
can.
know. Like my
That's basically my second question.
okay.
I mean, have you explored the possibilities of doing property-based testing?
Property-based testing.
Yeah.
I have to admit I don't know what that is.
Okay, I think it started with a Haskell library called QuickCheck, if I'm correct. And basically, if you're doing normal unit tests, you're just doing like 3 or 4 test cases, maybe just 10 or so. I mean, you are just capable of doing so and so many unit test cases. But if you're doing property-based testing, then you could just auto-generate these test cases.
Ah, okay.
I mean, if you're just testing a Boolean, that would be bullshit because you are just testing 2 states, basically.
Yeah.
But if you're just only testing an integer, I mean, that's 4 billion possibilities. So you can just check 4 billion possibilities.
Okay.
And if you're doing it just manually, you're never really testing the edge cases.
That's right.
But I don't know if it's possible in PHP.
I don't know either. But send me something because I'm
There
interested.
are ports of QuickCheck. So
Okay.
maybe there's a port for PHP unit.
Let's see.
Yeah.
I have my doubt that can work with Magento as well, but I don't know. Send me something and I will have a look at it.
It's really
But
great.
Yeah.
Do it.
Okay. Let's say my rule of thumb when I'm writing unit tests or integration tests is that I start working on a feature, I start writing the test for the feature. I try to do it test driven. So I start working on the test that fails, and then I try to write the code to make the test pass. In order not to write more code or not to implement features that I don't want to implement just because I found them cool. And in some cases, it's so hard to write unit tests of integrations tests about some of the features of Magento, or maybe some things are so obvious that I don't write unit tests. So not every corner of my code is tested. But I think I write tests for the core functionalities, and I try to write the tests that I feel are necessary. I'm not so keen on extreme programming, so that I have to write only test driven, and I have to write a test, an assertion per test, and all those rules. Because I think, like for instance, I have written, you have seen I had 15 tests and 65 assertions in this case. But most of these assertions were inside a test that proved that the mapping of a big object worked the way I expected. So that the object contained a lot of properties, and then each property gave the value back that I expected him to give back, to return. So in this case, I felt it was necessary to write 65 different unit tests because they will have repeated themselves. It's just a matter, if one of them doesn't pass, then you can identify the test more quickly. But in this case, like the mapping of a big object, then I wrote it like that. Because you have to balance in some, like, in an ideal world, I would write a test for a session. But in this case, I had to constrain it into the budget, let's say, of time that I had available.
So would you say that a test coverage or a code coverage of 100% is even possible? In
I think
Magento
it's
1?
possible, but you
Yeah.
have to invest a lot of time in it.
Yeah, of course.
Yeah. Yeah. It doesn't always fit the needs, let's say, or the time that you have available.
Yeah.
Yeah. So you have to try to make the best out of it.
So are you planning to do test-driven development then?
I try to do it as much as I can,
Yeah.
but not completely.
Okay.
I
Why?
cannot do it completely.
Why not?
Because sometimes it's a matter of time. It's mostly a matter of time.
Okay.
This is the.
It's a shame, Marcus.
No, but I try I'm trying to write even more tests as soon as more. I'm working on it and trying to write tests for every module that I'm working on.
You're gonna show a test?
Hmm?
An actual one? You're gonna show one?
Yeah. Of course. So the tests are in this directory. I have the fixtures here.
You make the font bigger?
Yes. You see it? Or bigger? So let's say in this case, I have the fixtures here. For instance, I have a shop fixture where I can just define all the basic data about the shop. And as I told you before, for instance, if you want to have the basic information about the shop, you have to write them in the database. This is already written in the database as soon as you run your unit test. And then you have the orders, for instance. So I created a fake order here with an ID of 17, which brings luck. Or bad luck. I don't
Where?
know.
In China or?
No, I just. and then I run the test. For instance, this is a. Let's see. Okay, this is a test. For instance, I load the shop feature, and then I load the order statuses available in the database, and then I check that the statuses returned by this function, which just fetches the statuses available as an option array, I just assert that the statuses contain the complete array, which is this one. Or in this case, I assert the statuses contain the closed status, which are defined in my order statuses pictures. So if I go to the order statuses pictures, I see that there are a lot of statuses, not just these ones, but I tested these two ones because I wanted to see if the mechanism is working correctly. So I wanted to test at least two of them. This is arbitrary. I could have written a unit test for each of the statuses here, but I don't think it's necessary in this case. It's just a matter of like looking at the convenience. Or for instance, I have an API method that returns an order if none of the statuses that I've shown before are selected in the configuration. Like in this case, I just update an order at the timestamp of an order, and then I call the API programmatically. So the API is called with the get model call, and then I export the first order that was not exported yet. And this is in the API response. And then I said that this is an object, and not null, for instance. And then the API response purchase order number is 17, which is the order that should be returned by the API. Such stuff, let's say. So this way I can make sure on the next one returns another if the order status is selected, or it does not return an order if the order status is not selected. And then I said that the response is different. This kind of stuff. So this is how it looks like when I'm working on unit tests.
But the customizations of the shop you put into the test, right? Because you had the payment method, for example.
Yeah.
It's not in the basic shop.
No, it's not in the basic shop.
You have to put the custom variables in there.
Yes, and this is the way you do it with the fixtures.
Okay.
Because with the fixture you can set as many data as you want, configuration data. You can activate payment methods, you can deactivate something else. You can add statuses, and you can basically configure the shop on runtime. And everything that you're writing with the fixtures will be deleted afterwards. So everything will be written once in the database, the test will run, and after each of the tests that we've seen, the data will be deleted from the database.
Mm-hmm.
So the database will be clean, and you start from scratch each time.
And you have created the test function or the methods from the module, but where do you collect the results? Single test you have called the
Which method do you mean as a people?
this result. You don't send to return for this function, but where do you collect?
Yeah. No, this is something that you get out of the box with PHP unit. You have the assertions,
Okay.
and then each one of the methods that is annotated with the annotation test is run by PHP unit. So basically, if you run this, you're running each one of these tests, and the assertions are verified. So PHP unit verifies that the content of the variable 2 is equal to the variable 1 that you passed.
Okay.
So basically, assert equal says, make sure that this corresponds to this. And you've called the real method here, with real fake data that you've put into the database.
Real fake.
Actual fake data, yes. Actual real fake data. So you put fake data in the database, and let's say you've worked on it, yes. And then you can make your assertions on this data, on the result. So you don't have to return anything basically, because PHP unit does that automatically. Yeah. I don't know if you have
Just to understand.
Yeah.
The fake data, the real fake data.
Yeah.
chance that the function is not working and it's returning the right result?
Like
It sort of feels a bit weird.
No, I don't. Could you make an example? Let's say.
I don't know. It just like you know you're testing a function,
Yeah.
so you're throwing in like a payment method.
Yeah.
And I'm just wondering if you always make sure that sort of the function is working because you're throwing in. Okay, I want to get back the payment method, and before that you put that into the database or what? For this order.
Yes. Yes.
Okay.
This is done automatically by the framework. But for instance, if you delete this line, so you deleted the line that said the selected statuses, and the test tests that it does not return any orders. If the order status is not among the order statuses that are selected, then the test fails because you've got a string instead of an object.
Okay.
Or maybe you got an object instead of a string. That means you've got an order instead of the status, no orders available.
Okay.
And if you put that back, like the first thing that you should test, so the way you write this test, you write it and you let it fail. And only this way you can make sure that the test is working correctly, because it fails before you implement the feature. Because if it passes, if you write the feature and then you write the test and it passes, you can never make sure that it doesn't pass if the feature is not there. You have to delete the code. But this way, you can make it fail, and then you can write the feature and make sure that it passes. If I put it back, it works again. Because the database is empty. It's empty each time. So basically the data is written by these annotations. Or maybe it's written by means of these annotations. Yeah. So this is the way to make sure.